All right, let's go on with one more example. I've got a rather simple example for you today. Um, and remember, I value your time, and so if you're doing really, really well with stoichiometry and you just want to zip over to the lab, watch the next video, and I'll take you through Virtual Lab 4, and you can move on. If you're still struggling a little bit, you need a little practice, or you're brand new to stoichiometry, that is okay. And this is a difficult process to get through. So if you just need more simple practice, keep on watching. All right, so these are the steps we go through. Those first 5 in red I went through earlier on the starter. We just write the complete balanced reaction. Step 6, we draw those lines and set up the problem. Step 7, write what you're given. 8, we're going to calculate the atomic mass by going to the periodic table. Number 9, convert the mass we are given into moles. We do some division there. Number 10, we do a little comparison and find the limiting reactant. Limiting means the one we're going to run out of first. And then we use the limiting one along with our product, and we do some cross multiplication there, cross multiply and divide. And last, a little multiplication and calculate the mass of the product. All right, let's go on over and we'll do a little example here. Get going on my iPad. Let's see here. Come on. There we go. It's Friday. There we go. All right, so let's go ahead and we'll do a little example here. I'm going to start off with a couple of elements, carbon and hydrogen, okay? And so the first thing I want to do is I want to write this in kind of the middle of my page, carbon plus hydrogen. I'm writing it large in the middle of the page, so I have lots and lots of space. And an arrow. That's step 1. Step 2, put them together. Now in this case, I know hydrogen is furthest to the left. It should come first. But in this case, this is a special molecule. It is methane gas. It's a covalent molecule. And the way that this works is hydrogen actually is the anion. It's sort of pretending that it has a charge of -1. There's some sharing going on. And so it looks like this, CH. All right, the next step, check for diatomics. Well, carbon's not diatomic, but hydrogen is, and it's by itself. On the right side, hydrogen's with the carbon, so no need for a little 2 on that one. And then we have a molecule to balance. This is +4 and 1 over there, so if we cross those over, we're going to end up with CH4. Okay. Last, we need to balance it. That makes 4 hydrogens on each side, and just finish it up with a couple of 1s. All right. So that's through those first 5 steps. I go through that one pretty quick because we've been doing this step since early March before we went on break. All right. That next step, draw some lines. 2 underneath each one. 1 on top. Remember, the ones on top are moles, and the ones on the bottom are grams. Remember, this one is atomic mass. We get those from the periodic table. These are the given numbers. I give you those. All right. Now that I've got the whole problem all set up, we can move on. I need to calculate some atomic masses, run over to that periodic table, and what you'll see is that carbon has 6 protons. It is element number 6, atomic number 6, but its mass for one of them is 12. Okay? Hydrogen, up in the upper left corner, its mass is 1, but I have 2 of them. Okay, 2 of them right there. So 2 times 1 is 2. And then in this case, I don't add up the 12 and the 2 and get 14. That would not be right. I have to add up the carbon. So the carbon, one of those times 12 is 12. The hydrogen, I have 4 of those times 1 is 4. And when I put those together, I get a mass of 16 grams. So notice it's not 12 plus 2. We have to add each one of these up separately. So this one, and that one, okay? And they each correspond to a mass. All right, we'll clean that up a little bit there. Okay, let's move on. Next step, write what we're given. Well, in this case, I'm just going to give you, because I'm generous today, 36 grams of carbon and 4 grams of hydrogen. And you got those because I made them up. I run the chemistry lab, so that's how much I'm giving you. So we're going to do a little division next. 36 divided by 12. Write the answer right up there. So that's 3. 4 divided by 2. Remember, do it in the order that they are. Don't flip them upside down. 4 divided by 2 is 2. All right. The next step, we have to figure out what we're going to run out of first. Over the weekend was Mother's Day. Hopefully you got a card or said Happy Mother's Day, gave your mom a hug. I made waffles for my wife. Grandkids came over and they enjoy the waffles. And so we talked about recipes. And fortunately, we didn't run out of anything other than chocolate chips, which my granddaughter likes in her waffles. And so that limited how many chocolate chip waffles I could make because we ran out of chocolate chips. Anyway, 3 divided by 1 right here. I'm just going to do that division and do that division. 3 divided by 1 is 3. 2 divided by 2 is 1. Remember, we're just doing that divide right there. And so this one over here, that is the smaller number. It's smaller because 1 is small. I'm not looking at that number. Okay? I'm looking at the division, the result of that division. All right. So I'm going to use this right here. 2 over 2 equals, go back and circle that for you right there, x over 1. Do my cross multiply and divide, and in this case, x is going to equal 1. And I'm almost done because I only have one more step, and that is to take the number of moles up there at the top and multiply it by the atomic mass. And so the atomic mass is 16. 1 times 16 is 16. And that is my final answer, 16 grams of CH4.